The user program was loaded onto the target system and is now processed in real time. Checking and, if necessary, correcting the program logic is the next step. On paper, a program logic can be followed very well. However, the real dynamic run behavior of a user program shows only in real-time operation. The Simatic Manager provides an excellent test function for this, the program status. Initially, the first main function is monitoring the program run. With the second main function, controlling, you actively engage with the program run. We show you the application in the programming language ladder diagram, and we start with monitoring a block. We open the monitored block directly in the user memory of the CPU via double-click in the online window. The program editor is automatically opened in this display mode. You activate the program status function via the monitoring button in the toolbar. In the program status, the editor constitutes the active binary program flow with a selectable color, green in this example, and shows the current signal status of the operands. If signal status and signal flow change, you will recognize this immediately in a change of color. This makes it very easy to recognize the program status and to trace the program logic quickly and simply. In the program status, parallel to monitoring the program run, you can additionally modify binary inputs and outputs as well as memory bits directly. This intervention has a direct impact on the program run and enables dynamic testing of all kinds of different program states. We show you two ways of controlling the operands. For control at contact, you first mark the operands in the symbol table, which is necessary for the intended test scenario. This promotes clarity in the later test mode. If the control at contact function has been selected and the program status activated, only the buttons for the marked operands are displayed. Clicking the button changes the value of the operand. Using the pre-selection via the symbol table effectively prevents unintended modification of operands which are not part of the test. Another means of direct modification is changing the status of an operand with the commands modify to 0 or modify to 1. Both versions have advantages. The control at contact function enables you to process even extensive test scenarios. Direct operand modifying is suitable for testing individual signal changes and their effect immediately and quickly. Naturally, the program status functions monitoring and modifying are also available for you in the language's function block diagram and statement list. In the programming language statement list, further language-specific functions are offered, such as the display of logic operation results or register contents of the Simatic Manager. In the preceding section, you monitored and controlled individual operands locally within a block. Using the global variable table, you can now also perform this on any other block and this way control the entire user program. An elegant method of preparing several test scenarios is the individual generation of different variable tables. These tables can be generated in the implementation phase and saved in the offline project. You have the option of commissioning individual machines, plant components, or also compiling individual variables for certain commissioning sections. This enables you to fix planned test processes in a reproducible manner. This table can later also be used for servicing and maintenance purposes. Insertable comments and the display of the symbolic names provide additional information on the individual operands. The display columns can be adjusted via the View menu. Additionally, you can also define conditions for reading and writing the variable values. In order to work with a variable table, we switch it online with the Monitor Variable button. Now you can monitor the status values of the listed global variables and define modify values. To do this, you enter the control value true and press the Modify Variable button. The signal change is directly displayed in the status value column, which in online mode displays the current signal status. An example will now show you how to combine the test functions variable table and program status in order to achieve the optimal overview in the testing phase. We activate the program status, which shows us the logic operation for operating a pump, and control the switch on via the variable table. The effects can be immediately observed in the program status. The pump output is activated. If against all expectations the pump switches off, the missing conditions can be immediately recognized in the colorized signal flow. With a variable table, you cannot only do monitoring and modifying, but also forcing. In the initial commissioning phase, for example, this function enables you to set still missing input or output signals to a fixed value, such as permanently switching on a pump independent of the program logic operations. This, as opposed to modifying with variable tables, enables you to define signal or variable values independently of the program sequence. The resulting advantages are: the program code does not need to be changed. No hardware jumpers in the wiring are necessary. The forced values are stored in a table and are therefore comprehensible. The forced values are marked in the program status with a symbol. In the project opened in the Simatic Manager, you select a predefined variable table and open it. You mark the parameters to be transferred to the force table. The menu command Display Force Values displays the force table valid for the CPU, and the selected variables are immediately transferred to the table with their control values. After activation, the CPU permanently executes the force job and indicates this at the respective operand as a force symbol. The status bar contains an indicator for the activated force operation, but the CPU also indicates this operating mode via a force LED. To provide you with information of forced variables at any time, these are marked online with a symbol in the program status or in the variable tables. So it is clear which variable values are predefined independent of the user program, so that misunderstandings can be effectively avoided. In large software projects, it is often difficult to keep track of the complex program structure or the numbers of used variables. The Simatic Manager supports you in this with the option of generating reference lists. On demand, the Simatic Manager compiles the desired overview compactly in the form of lists. The reference data most important in practice are program structure, assignment of variables, and cross-references of variables. The display of this data can be defined individually by means of filter settings. The program structure list shows the call hierarchy of the used program blocks within the user program. This enables you to understand and trace program sequences in the real plant during commissioning more easily. The assignment plan shows you which inputs, outputs, memory bits, times and counters in the program have been assigned or are still free. This helps you to avoid accidental double assignment of operands, for example at program changes. The cross-reference list shows you how and at which locations in the user program certain operands are used. This enables you to quickly find used operands in the program blocks. The cross-reference list, as well as the program structure list, enable you to quickly and conveniently jump directly to the location of the operand or block and make changes in the program editor. The reference lists are a powerful tool for better understanding the plant or machine intended for commissioning. This effectively helps eliminate misunderstandings and avoid errors due to inconsistent changes in the program or at the variables. Beyond the displayed main functions, the Simatic Manager provides you with further testing and commissioning functions. In the following, we will give you a brief overview. The single-step processing function, for example, with which you can edit each individual program instruction step by step. The current program status is displayed, and you can additionally monitor the variables in the form of variable tables. This combination of the testing functions helps you to understand even the most complex algorithms of a block, in order to intervene at the right location in case of an error. Last of all, we introduce you to the Compare Blocks function, which provides easy and safe merging between the online program in the CPU and the offline project on your programming device. In the detailed comparison, the program differences are listed, and in the program editor, the corresponding program locations are compared. A program correction can be performed immediately. This enables you to synchronize the different program states. Inconsistencies between the development level and the program code currently on the CPU are prevented this way. The test functions provided by the Simatic Manager enable cost-effective and reliable commissioning on time. In summary, this means quick and reliable setting of parameters with the editor of the hardware configuration, convenient commissioning by means of simple loading of changed program blocks during running operation, clear and targeted analysis of system or process failures by means of the diagnostic buffer, structured and convenient program model test by means of monitoring, modifying, and force functions, practice-relevant support by means of extensive information functions such as program structure, cross-reference list, or assignment list using reference lists.